Hey guys, here are your 6.5 day 2 notes. So yesterday's notes in day 1, you had to see the graphs of tangent, cotangent, cosecant, and secant. So today's notes are going to be about transforming those 4 graphs, all right? So the equations that they're going to look like now are going to be of this form. So you're going to have an A on the outside now, which is obviously on the outside, so you're multiplying your y's. That's going to cause a vertical stretch or shrink. You have omega times x on the inside, so your x's are going to be divided by omega, which means your period's going to be divided by omega, all right? And then you have this plus b on the outside, so that's going to be added to your y values. So you're going to have your vertical stretch or shrink like we've seen. You're going to have your horizontal stretch or shrink, and then this is new. This plus b is going to vertically shift the graph up or down to a new location, all right? But the important thing is we're not adding or subtracting anything to the x's yet, which means we're not shifting anything right or left, which is great because those are the worst transformations. All right, here we go. So just to review, A on the outside, you're going to be taking that A value and timesing your y values on that original first cycle to get your transformations, all right? Now, luckily, these 4 graphs, because they went to infinity and negative infinity, we didn't have an amplitude to worry about, okay? So you don't have to worry about multiplying your amplitude by that value. All right, now you're going to be taking your x's and multiplying them by omega, which means the opposite effect happens, and you're going to really take your x values and divide them by omega. When you do that, that's going to cause a period change, and it's going to cause a horizontal stretch or shrink. So remember, your new period has to be the old period divided by omega, okay? And then you're going to be taking this plus b on the outside. So you're going to be taking your y values and adding b to them, and that's going to cause a vertical shift up or down in the graph. Okay, all right, here we go. Let's try one. So they want you to use transformations to graph y equals 2 times the tangent of x minus 1. All right, and then use the graph to determine the new domain and range, if anything changed. All right, well, first of all, I think you should establish, well, who was the original function? The original function, before it was transformed, would have been the graph of y equals tangent x, right? And the graph of tangent x would have had a period of how many units? Because these are things that you should know. He would have had a period of pi units. Okay. Now remember, we use 4 main subintervals and 5 key points to graph the original first cycle. So if you take his period and divide it by 4, that means that we were accounting by increments of pi over 4 on each one of those subintervals. So you should be count by pi over 4. Okay, that's on the original graph. Okay, well, to kind of get an idea as to what his graph looked like, I always plug in 0. If you plugged in 0, what's the tangent at 0? Well, if you remember the tangent at 0, it happens at the point 1, 0. Y over x is 0 over 1. That's 0, 0. So that means 0, 0 is on his graph. So if you want to whip up a quick sketch of him, at 0, 0, it looked like that. So now if you remember what tangent function looked like, tangent function had to go like that. And he was sandwiched in between 2 vertical asymptotes. So that means that your 5 key points start behind 0. So now if we're counting by pi's over 4, we're 4 subintervals. His original ordered pairs would have been negative pi over 2, undefined, negative pi over 4, negative 1 would have been on his graph, 0, 0, pi over 4, 1 would have been on his graph. And then the last increment would have been pi over 2, and it was undefined. All right, but those are his 4 main subintervals that we would have worked with. Okay, 1, 2, 3, 4 subintervals, and it would have went from negative pi over 2 to pi over 2 on his first original cycle, okay? And again, you can look back at yesterday's notes if you need to get this information and kind of use it as a cheat sheet. I'm just trying to give you ways to kind of start from scratch. All right, well, let's see what the transformations are, because we're going to have to make transformations to these 5 key points to get the new graph. All right, well, it looks like that 2 is new, and he's on the outside. So that's going to cause us to do 2 times the y values, and that's going to cause a vertical stretch or shrink and no x-axis reflection. All right, if you notice, nothing's being done to x, so that means your period isn't going to change. There's no transformations in that horizontal direction. All right, the -1 is on the outside of the function because they would have had to use parentheses if they wanted it on the inside. So the -1 is on the outside, which is again happening to y's, so that means you're going to take your y values also and subtract 1 from them. So that means there's 2 transformations to this graph, and they're both happening to y. So that means your period is still going to be pi units because nothing happened to x's. And again, if you take that period and divide it by 4 to create your 4 subintervals, you're still going to be counting by pi's over 4. So I'm going to label my x-axis to get myself ready. All right, so 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 is really 3 pi over 2, and then you have 7 pi over 4, 8 pi over 4 is 2 pi, and I can probably stop. I'm just giving myself more increments if I wanted to continue the cycle. All right, and then I can go back, -1 pi over 4, -2 pi over 4, which is negative pi over 2, -3 pi over 4, and then -4 pi over 4 is negative pi. Okay, all right, so now let's make the changes to these 5 key points and we should be good to graph our new transformed graph. All right, so this ordered pair is going to become, well, nothing happens to the x's, so it's still going to be negative pi over 2. And now take the y value, which is technically undefined, times it by 2 and -1. But I don't have to do that because nothing's going to change undefined. Okay, go to the next ordered pair. Negative pi over 4 doesn't change because nothing happened to the x's. Take -1, times it by 2, that's -2, and now subtract 1, that's -3. All right, go to your next ordered pair, which is 0, 0. 0 stays the same because I don't do anything to the x's. Now take 0, times it by 2, and subtract 1. That'll be -1. Okay, all right. Now we go to the next ordered pair, which is pi over 4. Sorry, I got distracted. Pi over 4 stays the same. Now we take 1, we times it by 2, and we subtract 1. So that's still going to be 1, just the way the math works out, okay? And then pi over 2 stays the same. And then you take undefined, times it by 2 minus 1, and you can't do that, so it stays undefined. So this is the new first cycle of the transformed tangent graph. All right, so let's plot what we got. Negative pi over 2, undefined. All right, negative pi over 4, -3. 0, -1. Pi over 4, oh, not on the graph, sorry. Pi over 4, 1. And then pi over 2 undefined. And that's the new transformed cycle of the tangent graph. Now, sometimes they ask you to graph multiple cycles, which is fine. You'll be using probably the online graphing tool, so it shouldn't matter. But the pattern will continue now every pi over 4 units. So now, see how undefined came out? -3, 0, I'm sorry, -1, 0, undefined. So now we're back to undefined. So now -3 will come back out. -1 will come out next. Then 0 will come out. And then we're back to an undefined. And you've just created yet another cycle of the tangent graph. And then you can go again. -3, -1, 0, undefined. And you can keep creating cycles of your tangent graph. Okay? All right, let's go to the next problem. Oh, I need another sheet of paper that went through. Okay. All right, let's look at this one. Now you have to graph y equals 3 times the cotangent of 2x. All right, well, first of all, let's establish some get started information, right? Who were your main subintervals? What was your main function? What was his main period? And so on. So this would have started as y equals the cotangent of just x, right? That would have been the original function to that one before it was transformed. All right, so what was his original period? His original period, cotangent, just like tangent, had a period of pi. So now, his original graph, if you had created 4 subintervals, you would have taken his period, divided it by 4, and you would have had subintervals that counted by pi's over 4. So he would have counted by pi over 4 originally. Okay, all right, we'll come back to that. And then where did he start? Well, I always kind of plug in 0 kind of around that origin to see what he did. So if you plugged in 0, the cotangent at 0, right? Well, picture 0 radians, that's the point 1, 0. X over y would have been undefined. So if you remember, the cotangent function actually started right at 0 at an asymptote. So if you picture his graph now, it would have been an asymptote. He was a decreasing function from left to right, and then he was squeezed in between another asymptote is what his graph should have looked like. All right, so let's see if we can remember what those 4 main subintervals were and what those 5 key points were. Well, if I had to count by pi's over 4 and he started at a 0 undefined, that means his first point would have been 0 undefined, and then I would have counted by pi's over 4. So pi over 4, and then remember, he was a decreasing function, so 1 came out first, then it would have been pi over 2, 0, and then it would have been 3 pi over 4, negative 1, and then last would have been pi back to an undefined. And those were his 5 key points. Now again, if you can't recall them, just look them up in your notes from yesterday. Okay, here we go. Let's see what our transformations are going to be now. Okay, it looks like we have to do 3 on the outside, so that's going to be 3 times the y's. I'm not on camera today, sorry guys. 3 times the y's, causing a vertical stretch, no x-axis reflection because it's not a negative number. And then look, we are affecting the x's this time. This says we're taking the x's and timesing them by 2. So we know the opposite is happening. We're taking the x's and dividing them by 2, which therefore is going to cause a period change. So you also are taking your period and dividing it by 2. So who was the period? It started as pi, divided by 2, and now your new period is pi over 2 units. So it's only, oh, that's the new period. So it's only going to take pi over 2 units to create one of these cotangent curves, okay? So now if you want to get yourself set up, since the new period is pi over 2, if you take your new period, pi over 2, make sure I'm on camera, and divide it by 4 to create 4 subintervals. Let me just clean that up. Times by a 4th, times by a 4th. That's pi over 8. So your new graph is going to count by pi's over 8. That's going to be your new counting increment to create those 4 subintervals off of this new period. All right, and again, you don't have to do this because you'll get the new x values by doing this anyway, but I kind of like to get myself set up to know who I'm counting by. So pi over 8. So I'm going to go and just start labeling and count by pi over 8. So 1 pi over 8. 2 pi over 8 is actually pi over 4. 3 pi's over 8. 4 pi's over 8 is actually pi over 2. And then 5 pi over 8. 6 pi over 8 is actually 3 pi over 4. 7 pi over 8. 9 pi, did I skip one? That would be 6, 7, 8 pi over 8 would be pi. And then you'd have 9 pi over 8, and so on. I'm pretty much sure I can stop. I have enough increments to set me up for the future. All right, I'm going to go backwards. Negative 1 pi over 8. Negative 2 pi's over 8 is actually negative pi over 4. Negative 3 pi over 8. And then negative 4 pi over 8 is actually negative pi over 2 when you reduce it. All right, so my increment should be pretty much set up. But like I said, that's just something that you can choose to do. You don't have to do that. All right, let's make our changes. Okay, so first things first. First, I have to take my x's and divide them by 2. So 0 divided by 2 is still 0. Now I have to take my y value and times it by 3. But an undefined times by 3 is still undefined. Okay? All right, now I have to take my x and divide it by 2. So pi over 4 divided by 2 is pi over 8. All right, take your y value and times it by 3. That's 3. All right. Take your x value, divide it by 2. Pi over 2 divided by 2 is pi over 4. All right, and then take your y value and times him by 3, so that's still 0. All right, we go back. 3 pi over 4 divided by 2, and that's 3 pi over 8. Take -1, times it by 3, and that's -3. And then last, take pi, take your x, divide it by 2, that's pi over 2. And then take your y and times it by 3, but that's still undefined. And now these are the 5 main key points that live on your transformed cotangent graph. All right, so 0 undefined. All right, pi over 8, 3. Pi over 4, 0. 3 pi over 8, -3. Pi over 2 is undefined. And there's your new transformed cycle of the cotangent graph that has been vertically stretched and horizontally shrunk. Okay? All right, and again, the pattern will repeat now. So now we're back to undefined. So now 3 will come back out, 0, -3, and then you're back to an undefined. And then you've just created yet another cycle of this transformed cotangent graph, okay? All right, perfect. All right, well, I forgot to do this in the first one, so I'll do it now. They did ask for the new domain and range. Well, what's your new domain? Well, think about it. What are the bad x's? The bad x's are 0, pi over 2, pi, and then the next one would be, I'm assuming we're going by what, 90? This is every 90, 90, 180, and I'm assuming 270. 3 pi over 2 is going to be the last one. So you have to say x cannot be 0, and then plus or minus. The first bad one and the next one are always pi over 2 radians away from each other. So plus or minus pi over 2 times k revolutions. X is not allowed to be that. All right? Now, if you want, another way, I'm trying to think of what I saw in the online. The online, I think, actually let you do, since it's really going to be 0, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and so on. They said, or you could say x cannot be k times pi over 2, where k is an integer. So that might be another option that they give you on the online homework, all right? And then your range is still going from -infinity to infinity. All right, I'll go back. I'm going to do this one again. Where was the other one? I just want to write his domain and range down. So your domain and range for your first one, domain is who? X can't be pi over 2, 3 pi over 2, then 5 pi over 2. So x cannot be, it looks like odd integer multiples of pi over 2. So pi over 2 is the first bad one, and then plus or minus, let's see, that's 92, it's pi radians in between times k rotations, all right? Or they might let you do, since it's odd integer multiples of pi over 2, they might let you say x cannot be k times pi over 2, where k is an odd integer, because they start writing it in all different kinds of ways in the multiple choice on your homework. All right, and then the range is still -infinity to infinity. All right, last one more problem and we're done for today. All right, last one. Graph y equals 2 times the cosecant of x minus 1. Well, the good news is that I noticed right away is that they didn't do anything to x. So it's not changing our period. Everything's just happening to y. This 2 is on the outside. This minus 1 is on the outside. So I don't have to worry about my x's changing. All right? Okay. Well, let's see if you remember what the original graph of cosecant x looked like, right? So we get our original information. So y equals cosecant x, right? If you remember, he had an original period of 2 pi units. And if you can picture his graph, it was the up parabola, down parabola, up parabola, down parabola type looking graph. All right, well, if you want to get yourself remembering his 4 subintervals, if you took his period 2 pi and divided it into 4 subintervals, his graph was counting by pi's over 2. Count by pi over 2 when you go to get your key points that lived on his first cycle, okay? All right, so if we count by pi's over 2, well, first let's get an idea as to where it started. So if you plugged in 0, what's happening at the origin? What was the cosecant at 0? Well, remember, the sign of 0 was 0. So when 0 went into sign, 0 came out. So the reciprocal of 0 comes out of the cosecant function, which would mean undefined. So that means he started at a vertical asymptote. So he was a vertical asymptote, up parabola, vertical asymptote, down parabola, vertical asymptote. That's what his first cycle looked like. So his main key points counted by pi's over 2, and it started at 0, undefined. All right, then it went to pi over 2, and then it had a 1, right? That parabola started at a 1. And then it went to the next, it went to pi, because we're counting by pi's over 2, and that was a VA, undefined. Then it went to 3 pi over 2 was your next increment, and then that was -1. And then it went 1 more pi over 2, which brought us all the way to 2 pi, and it ended at a vertical asymptote, so undefined. So these were the 5 key points that lived on that first cycle of the cosecant graph. And again, if you don't remember these, just look back at yesterday's notes. All right, let's make our transformations and be done. All right, so we're going to do 2 times the y's, and we're also going to do y's minus 1. So there's 2 transformations happening to the y's and nothing happening to the x's, which means your period will still be 2 pi units because you didn't change the x's. And if you take 2 pi and divide it into 4 subintervals, you're still going to count by pi's over 2. So if you want to get your x-axis set up, that's good. You can do that right now. So I'm just going to go set up my x-axis because his graph should still count by pi's over 2. Pi over 2, 2 pi over 2, 3 pi's over 2, 4 pi's over 2, 5 pi's over 2, 6 pi's over 2 is 3 pi, 7 pi over 2, 8 pi over 2 is 4 pi. And then we can go back, -1 pi over 2, -2 pi over 2, -3 pi over 2, -4 pi over 2 is -2 pi. And then we should be pretty much set up to go. Even though you would have gotten these values by doing your transformations, I kind of like it to have it set up so I can continue the pattern. All right, here we go. Let's make our transformations. So nothing is happening to x, so it stays 0. Take your undefined, your y, times it by 2 minus 1, but it's still undefined. Okay? Take pi over 2, leave it alone because nothing happened to the x's. Take 1, times it by 2, which is 2, and minus 1, and it's still 1. All right, leave your x alone. Take your undefined, times it by 2 minus 1, but that's undefined. All right, leave your x alone. That's 3 pi over 2, times it by 2, that's -2, and then minus 1, so that's -3. And then 2 pi stays the same, x's didn't change. And then take your y, times it by 2 minus 1, but that's still undefined. And these are your new points on your transformed graph. So we have 0 undefined, pi over 2, 1, pi undefined, 3 pi over 2, -3, because of that vertical stretch and that shift, and then 2 pi undefined. And because there was no x-axis reflection or anything, it'll still stay in that up parabola, down parabola pattern. And then you can go again. Then your undefined came out, so now you're back to a 1 coming out. Then you'd be back to an undefined coming out. Then you'd be back to a -3 coming out. And then you'd be back to an undefined coming out. And he would start that whole up parabola, down parabola pattern. And now you've created 2 new cycles of your transformed cosecant graph. All right, well, what's his domain? The new domain, who can x not be? X can't be 0, pi, 2 pi, 3 pi, 4 pi. So x can't be 0 plus or minus pi times k rotations, right? Or they might let you say, oh, that can't be. X cannot be, let's see, it would say k times pi or pi k, pi times k, if k is an integer, right? You only had to be 1 pi, 2 pi, 3 pi, k is an integer. All right, and then your range is, let's see. Now remember, he's got this big gap of y values that don't come out of his graph. So his range is coming from negative infinity to negative 3, and then it jumps up to 1 to infinity. So it's negative infinity to negative 3. Union, it jumps up to 1 to infinity. Okay? All right, guys, that's it. That's section 6.5. Those are your transformations on your tangent, cotangent, cosecant, and secant graph. So again, it's all about that first cycle, those 5 key points, those 4 subintervals, and then making the appropriate changes that were caused by the changes made to his equation. All right? All right, good luck on your homework. If you need anything, just text me, and I'm here to help. Good luck.